Good morning. So in the last class related to quadrilaterals, we have solved few problems. Today related to midpoint theorem, we will discuss the one more exercise, children. Okay. So first we should know what is midpoint theorem. So it says that the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. This is the thing they are having. Okay. So we have to draw a line through the midpoints of one side. Okay. It will be parallel to the other side and it bisects this side. So the meaning of this is, see here, this is a triangle. So E and D are the midpoints of AB and AC. Then DE is parallel to BC. And the one more thing is, DE is off of the BC. This parallel side will be off of this parallel side. So this itself is a midpoint theorem. Now related to this, we will be having few problems. Let us discuss one by one. Here the first question is, ABCD is a quadrilateral in which P, Q, R and S are the midpoints of the sides AB, BC, CD and DA. So AC is a diagonal. Show that, what you have to show? SR is parallel to AC. SR is parallel to AC, diagonal. For the diagonal it should be parallel. And one more, SR is off of the diagonal. That is the first thing you have to show. The second thing you have to prove is, this SR is equal to the PQ, the one more side. And finally you have to prove that PQRS is a parallelogram. Okay, so these are the things you have to prove from this figure. Now, so let us take this triangle first, ADC. Okay, so S and R are the midpoints of AD and DC, isn't it? Okay, that's why. According to midpoint, if they are the midpoints, then the side will be parallel to what? The third side. So SR is parallel to AC. Even one more thing, SR is what? Off of the AC. Call it as a 1. Okay. Now we got the first proof. SR is parallel to AC as well as SR is off of AC. We got the first one. Now we will move to the second part. Take this triangle now. ABC you take down. In triangle ABC, P is the midpoint of AB, Q is the midpoint of BC. That means PQ will be parallel to AC. Same from midpoint theorem. Okay. If it is parallel, then PQ will be off of AC. Isn't it? So call it as a 2, call it as a 1. You can observe RHS parts are same. So that's why LHS are also same. Therefore, PQ will be equal to SR. We got the second proof also. Now the final proof is PQRS is a parallelogram. That is the thing you have to prove. Already we got this side is equal to this and this side is parallel to this. Now what we have to do? We have to draw one more diagonal here and automatically that time SB will be parallel to DB and off of DB and RQ will be parallel to BD and off of BD, isn't it? So let us go with that proof. We will got this SP will be equal to RQ. So third one already we got that. What is the third thing we are having? PQ is equal to SR we are having. Now here we got SP is equal to RQ. So we got the opposite sides as a equal. Therefore we can say that PQRS is a parallelogram. So that problem completes. Now we will move to the second problem. What is the second problem? ABCD is a rhombus and P, Q, R and S are the midpoints of the side AB, BC, CD and DA. Show that quadrilateral PQRS is a rectangle you have to show. We got one quadrilateral now here. This will be rectangle. That is the thing you have to prove. So rhombus you draw. What is the property of a rhombus? All the sides are equal. Okay. Now in that all these are midpoints. So let us join one diagonal there. So DAC, AC I have joined. BD also you should join. Here you check it out. In ADC triangle, S and R are the midpoints of AD and AC. That's why SR is parallel to AC. And even SR is half of AC. Isn't it? Call SR parallel AC as a 1 and SR is equal to half of AC as a 2. Now, in BAC, this triangle, PQ is parallel to AC. Same from midpoint theorem. Here also midpoint theorem. Here also midpoint theorem. If it is parallel means automatically it will be half of AC. So check from these two things we can say that SR is parallel to AC and they are equal. Even PQ will be parallel to AC and SR is parallel to AC. That's why SR is parallel to PQ also and they are equal also. Okay, here only we got that proof. So, since ABCD is a rhombus, we know that diagonals bisects at right angles. That's why DOC will take as a 90 degree. Okay. So, since we will join, we will give the points here. It has a O, it has a U. Already R is there. This point I am giving as a T. Okay. Now, since SR is parallel to AC, even this part, TR is also parallel to AC, that is OU. Call it as a phi. And we know that QR is parallel to BD. That's why UR will be parallel to OT also. Now we got opposite sides as a equal. That's why it is a parallelogram. But what is the thing we had to prove here? We had to prove each angle. Even this angle 90 we had to prove. So we know that in a parallelogram opposite angles are equal. So if it is 90 means this angle will be, that is TRU will be 90 degrees. Isn't it? So that's why. In the same way, if we go with this angle also, even this will also become 90 by the same way. Even this also 90 and this also. All the angles become a 90 degree. Therefore, PQRS is a rectangle. Got it? So, this is the proof. Now, we will move to the one more problem. So, in a parallelogram ABCD, E and F are the midpoints of side AB and CD respectively. Show that the line segments AF and EC trisects the diagonal BD. Okay, this is the thing you have to prove. So, what is given? Just to check it out. E is the midpoint of AB they have given and F is the midpoint of CD they have given. But already we know that it is a parallelogram. In a parallelogram, opposite sides are equal. That is AB is equal to CD. Here, AB can be written as AE plus PE, no? CD can be written as CF plus DF we can write. So, equal sides they are. So, instead of BE, I am writing AE only. Here also, instead of DF, I am writing CF only. 2 AE, 2 AE, CF, CF, 2 CF. 2 get cancelled. A will be equal to CF and they are parallel also. Okay. Now, so this one we will take. AE, CF we will take. Here already we got that AE is parallel to CF. One pair of parallel sides we got. Okay. That's why it is a parallelogram. By that, AFV is also parallel to EC and they are equal sides also. Okay. Now, we will go with the DSC triangle. This triangle we will take. In this triangle, EP will be equal to CS, not equal, parallel to ES, isn't it? So, F is the midpoint, that's fine. Even P also becomes a midpoint of DS. If P is the midpoint of this means DP will be equal to PS. Call this as a 1. We are taking the converse of BPT here. When the lines are parallel, the points will be midpoints. That is the thing we are taking. In the same way, in triangle ABP, this triangle, E is the midpoint of AB means then S is also a midpoint of, because this is parallel to this. SE is parallel to AP. If they are parallel sides, S is the midpoint of BP. That is the thing I am proving here. Okay, that's why BS is equal to PS. Call it as 2. So 1 what we are having, DP is equal to PS we are having. 2 we are having, BS is equal to PS. From 1 and 2 we can say there are 3 equal parts. So the line BD is divided into 3 equal parts. So it is a trisected. Okay. Now we will go with the last problem of the exercise. ABC is a triangle, right angled at C. A line through the midpoint of M of a hypotenuse AB and parallel to BC intersect AC at D. Okay. Show that D is the midpoint of AC. First thing, MD is perpendicular to AC and CM is equal to MA is equal to half AB. This is the thing you have to prove. Now we will move to the proof. This will be the figure you will be having. So it is a right angle at C. Okay. So M is the midpoint of the hypotenuse. From there we are drawing a line that is parallel to BC. They only said. Okay. This is the picture. So here MD is parallel to BC. So D is the midpoint of AC now. Because when the lines are parallel, these will be the midpoints. M is a midpoint already we know. That's why D is also a midpoint of AD. First one we got. Okay. Second proof, what we have to prove? MD is perpendicular to AC we have to prove. Okay. So already we know that DM is parallel to BC. So AC is the transversal. These two are parallel sides we will take and this as a transversal we will take. Already it is 90 degree. So sum of interior angles is equal to what? 180 degree. They are supplementary. So if DCB is 90 degree, what about MDC? We have to find 180 minus 90. We are getting it as a 90 only. So that means MD is perpendicular to AC now. We got the 90 degree, that's why it is a perpendicular. Now, to prove the third thing, we have to join M and C. Now we got two triangles here. So MCD is 1, MDA 1. Consider those two triangles. What are the equal things you are getting? Just check it out. We got this as a 90, even this will be 90 degree only. And already we know that D is a midpoint. Therefore, CD is equal to DA. That is AD is equal to CD, midpoint. And MD is the common side for both the triangles and on right angle. So from RHS postulate, you can go with the congruency. They are congruent. If they are congruent, the left side is CM and AM. They will be equal. So, therefore, already we know that M is a midpoint of AB. That is half of AB. That's why when AM is equal to CM, even CM will be half of the AB from the midpoint theorem only. Okay. So this completes quadrilateral lesson. In the next class we will go with the new lesson. Thank you, children.